ArcGIS is geospatial software to view, edit, manage and analyze geographic data. Esri develops ArcGIS for mapping on desktop, mobile, and web. ArcGIS includes different software such as ArcMap, ArcCatalog, ArcScene, ArcGlobe, etc. ArcMap is Esri's classic desktop geographic information system software for creating, analyzing, and visualizing spatial data and maps, which in this tutorial we mostly focus on ArcMap. In this tutorial, we're trying to show you how to work with ArcGIS software. If you have any questions or problems, ask us in the comments, and if you need a specific tutorial on ArcGIS software, let us know in the comments to record a video. First of all, you need to download and install the ArcGIS software. If you couldn't find its installation file or download link, we've provided its download link in the description. After installing the ArcGIS package, you should go to the Start and look for ArcGIS folder. In the ArcGIS folder, you can see different software such as ArcCatalog, ArcGIS Administrator, ArcGlobe, ArcMap and ArcScene. Our goal is to work mostly on ArcMap, so here we click on this software and open it. It might take a little time if you open it for the first time. When ArcMap is opened, a Getting Start window pops up automatically. In this window, if you already have a saved project, it will appear, and by selecting each one, the same previous project will be displayed for you. And if your project is not displayed in this window, you can use the Browse option to import that project into the software from the save path. The ArcGIS file format is MXD. Also, a series of standards for the initial display of the software have been placed inside ArcMap, which you can view by clicking on each one. If you need any of these templates, you can display it by double-clicking on it. From the New Map option and My Templates submenu, we start with an empty project or blank map. You can change its saved path if you'd like to, but changing the saved path needs creating a geodatabase, which we go to in the continuing. We accept the default geodatabase for now and click on OK. The name of the project is written as untitled. When you save the project, you can set a name for it. By right-clicking on the top page of the software in a blank area, you can access lots of tools that you can turn on or off each one. Here I remove the extra tools and turn them on again whenever needed. The two Standard and Tool are our important tools to start working with the software. You can move any tool or even place it on the screen and customize them. In the File tab, you can change the page and print layout, save and make a series of other settings. The next sections include Edit, View, Bookmarks, Insert, Selection, Geoprocessing, Customize, Windows, and Help. We will give the explanation of each section during the video. In the Help section, you can see the installed software information such as its version, platform, other installed application and so on. Also, in the ArcGIS Desktop Help section in the same tab, you can search for any problem you might deal with in the software and solve it. The explanation and help section of all parts of the software has been categorized on the left side so that you can search based on your need. Here on the main window you can see different sections. The first important part is the table of contents. This window will show you the layers you import to the software and let you make some changes on the layers, open the attribute table of each layer and so many other features. You can change the location of this window and place it anywhere you feel comfortable with. By clicking the Auto Hide option, the window opens and closes automatically. You can auto hide some windows, but some windows like the table of contents should be kept fixed. On the right side, you can see the search window. Using this tool you can find and run all the tools and commands you need. The next tool is Catalog, which allows you to view the software catalog. Create Features window, which will be used in the rest of the video. And finally, the important part of ArcGIS software is Arc Toolbox, where all the tools are categorized in this toolbox. You can use this tool to perform any processing and operation. From the Windows section, you can turn on and off the table of content, catalog, and search tools. This operation can also be done in the Tools section. To get started, you need to import your data to the software. There are several ways, one of which is to use Add Data option. Go to the File tab and select Add Data. Data can be imported to the software in different ways. Select the Add Data option again. By clicking the Connect to Folder option, you can connect your data folder or add other folders if needed. And import any data you need to the software. Here we selected a city shapefile. As you can see, the Add Data option has been placed in the software header directly. You can use that as well. From the Table of Contents section, right-click on the imported layer and click the Open Attribute Table option. Each layer has an information table that is called an attribute table. Using this feature you can access every layer's information and make changes if needed. By moving it, you can minimize or maximize it and place it anywhere you'd like to. You can see 4 columns in the table, which are called fields. Likewise, each row is called a record. The first 2 fields of each shapefile are exclusive and cannot be edited. But you can edit the rest of the fields and even add new fields and records. By clicking on each record, the corresponding feature will be highlighted. You can also identify the layers inside the table using the Identify tool. The process by which the pixels of an image are given geographic coordinates is called georeferencing. In other words, it can be said that old maps that are in photo formats, such as JPG, do not have geographic coordinates. In the process of georeferencing, we give each pixel in the map a geographic coordinate so that remote sensing and GIS software can import and process them. To perform georeferencing, import a map to the software. In the corners of the map, the coordinates are recorded in degrees and minutes. Using these points, we can georeference the map. Right-click in the blank part of the software and select the georeferencing option. The georeferencing tool will be displayed for you. If you have several layers inside the software, it is better to introduce the map on which you intend to georeferencing to the georeferencing tool. Also turn off the Auto Adjust option. Click on the Add Control Points option. Zoom into the corner of the map to do better. Click exactly on the left corner of the map. Here you can perform georeferencing in two ways. The first method is to use X and Y. The second method uses DEMs of longitude and latitude. In the second method, you need degrees, minutes and seconds. We do with the first method. For X you must write 52 degrees, and convert 30 minutes to degrees. 30 minutes will be 0.5 degrees. In the same way, do the other three corners of the map. We must have 4 control points so that the map is correctly placed on its coordinates. After completing the 4 corners of the map, you can zoom to layer. Select Auto Adjust. Zoom to layer again. Here the map is exactly on its correct coordinates. So it is necessary to take an export from the map. Choose Rectify from the Georeferencing section. Specify a path to save the file. Create a new folder in your desired path. Click on the new folder and select Add. You can also write the name of the map in the Specifying Name section. And by clicking on the Save option, the desired file will be saved with coordinates. And you can import the georeferenced map into the software. Now we want to show you how to create different types of shapefiles. To briefly explain, the shapefile format is a geospatial vector data format for geographic information system software. It is developed and regulated by ESRI as a mostly open specification for data interoperability among ESRI and other GIS software products. So, firstly import the georeferenced map into the software. Make sure you've imported the georeferenced map, not a non-georeferenced map only. Then from the right side, go to the Catalog section. Go to the storage path where you want to save the shapefile in. Right-click and create a new folder and set a specific name for it. We are going to create all the shape files inside this new folder. Right-click on the SHP folder. By going on the new option, a list expands. The Create New Shape File window displays the specifications of the shape file you are going to create. Here we must set a specific name for our shape file. Also, select its feature type based on point, line and polygon. It depends on your need to create which type of shapefile. To accurately create a shapefile, we must determine its coordinate system, otherwise it doesn't fall on our map. So using the Edit option, we adjust the shapefile coordinate based on our georeferenced map. Here you can choose the coordinate system you want. If you do not know the exact coordinate system, you can set the coordinate with the help of an image or a map that has the coordinate system. For this purpose, using the sphere icon, select the Add Coordinate System option. You can define an image or a map through the Import option. Here the coordinate system of the map is placed on the shapefile. Now the shapefile of the village has been created as a point. In the same way, we create two other shapefiles as line and polygon. All the desired shape files were created here. In the same way, you can create your own shapefile. Now in this section, after creating our desired shapefiles, we will digitize the map. To digitize, we needed to create a shapefile, which we created already. Now we can digitize using these shapefiles. We need to activate the needed tools, so right-click on the blank part of the software. The needed tool for digitizing is the Editor tool. Find the Editor option and click on it. Using this tool, we can do the digitizing operation well. Since we created new shapefiles, if you go into the attribute table of each shapefile, you will see that there are no fields or records. Click on the Editor and select Start Editing. By clicking on Start Editing, the Editor tools turn on. Select the Create Features option among the Editor tools. Its icon looks like a notepad with a pen. A window opens in the right side. You can see the shape files there. By clicking on each one, you can digitize that feature. Also, by clicking on each one, you can see the corresponding templates in the Construction Tools section. So click on the shapefile. The mouse pointer has become a point, which means that you can now digitize the points you want. The selection of our points is not accurate at all and is only to show the process of doing the work. Make sure you select your points precisely. You can change the symbology of the points to make them more visible. As you can see, the attribute table has fields and records now. Select the road shapefile and start digitizing. You can collect the linear features using this class. Pay attention that you need to create a special shape file for each specific feature. For example, you need to create a shape file to digitize water lines. And to digitize road or street lines, you need to create another shape file. To draw polygons and features that are in the form of surfaces and polygons, do the same as the previous methods. After getting the digitizing done, you need to select the Stop Editing option from the Editor section, and save the edits. You can set a special and different symbology for each class. The Symbology helps to clarify which class is which and makes your map clearer and cleaner. One of the most important and basic tasks that can be done in ArcGIS software is to create and complete the information field of the layers. After creating the shapefile layer and digitizing the map, you will need to enter the necessary information for each layer. For this purpose, watch the rest of the video to see how to do this. We have already created our layers. Go to one of these layers and right-click. Click the Open Attribute Table option. The Open Table shows all the information of a layer. You're able to enter new information or edit a series of information using this table. Here we are going to insert a series of information into the layer, as an example. For this purpose, we activate the Editor option. To enter information and edit them, the editor must be active. Go to Table Options and select the Add Field option. Set a name for the new field. Also specify the type of the layer. A new field has been created here. Activate the editor and enter the corresponding name for each layer. Because of the educational aspect of this tutorial and just to show you, we just enter irrelevant letters. But you'd better enter the correct information. After filling the fields, turn off the editor and save the changes. You're better off creating a new field again and testing several fields to learn well. Here we add the X and Y coordinates for the layer. You can add any information you have from your new layer. By clicking on each layer, you can view the saved information. This method is to add information and edit them to the layer. You can add different fields to all your layers in the same way. All layers are prepared in the same way. When you imported the data into the software or generate it yourself, you need layer symbology. Symbology of layers makes visual display of layers better and easier. For this purpose, here we've imported a series of layers in the software to choose the appropriate symbology for them. From the table of contents section, below the imported layers, there is a symbol that shows what that layer is. For instance, it's a point layer or a line layer. By clicking on that symbol, the symbology window of that layer is open. In the symbol selector window, you can see all types of symbology. You can even search for the appropriate symbology. You can choose the symbology based on the type of layer you have. You can change size, color and other changes to your symbology to have a better and more attractive map. And the most important reason is the similarity of the symbol with the phenomenon in the real world or nominally. You can choose the appropriate symbology for all your layers. Here we search the river. We also select for the polygon layer, which is the area of a city. We can import other types of layers to the software. In this section, we go for the layout of the map. In order to get a layout map, follow the steps. Since we are in standard view by default, we should change it to the layout view. Using the little icon on the left corner of the main window, we can change it to the layout view. Afterwards, from the File menu, select the Page and Print Setup option. In the open window, you can make settings related to the page and the print. The first and most important one is to determine the orientation of the map. It could be either portrait or landscape. We put it on portrait. We adjust the dimensions of the map based on the output dimensions. From all sides, the map should remain the same so that it looks more visually appearance in the output. We leave some space around to add the grid. By right-clicking on the map and using the properties, you can make more settings. One of these settings is specifying the color of the map frame. You can choose any color if you like. You can also choose a suitable grid from the grid section. Each grid has a series of settings that you need to make. Here the longitude and latitude remain constant. As you can see, one side has more grid. So we have to adjust the coordinates from both sides. Go to the Properties section of the created grid. In the Labels section, you can make the labels vertical or horizontal. You can also change the font size and enlarge its dimensions so that it can be seen better. In the Insert menu, you can add other items to your map. The most important of them is the map legend. In the legend window there are two sections. The left side is the imported layers to the software and the right side is the layers that will be shown in the legend. You can transfer the left side layers to the right side to be shown in the legend too. In the next step you can change the font of the legend. You can add a background to the legend frame if you'd like to. And you can also change the type of symbology. After adding the legend, we place it somewhere on the map. The next thing we should add is the north arrow. Using the Insert menu we can add it to our map. And put it in the right place on the map. You can do this to select the frame. Then we need a scale bar. From the Insert menu choose the right scale bar for your map. You can change its settings for a better display. You can change the font of the numbers as well. I think the backgrounds are not suitable, so we remove them. You can also add a scale text to your map, it's up to you. Now we need a title to assign a name to the map. Choose the appropriate font and size. You can set a suitable color for the city border. And finally, export the map. To the export map we have to go to the File menu. Set the save path. Enter a name for the output map. And select Save as Type. You can export to any format you need. You can increase the resolution of the map. And finally you can see the output of the map here. In ArcGIS there are useful tools that are called Geoprocessing Tools. Geoprocessing is a framework and set of tools for processing geographic and related data. The comprehensive suite of geoprocessing tools can be used to perform spatial analysis or manage GIS data in an automated way. A typical geoprocessing tool performs an operation on a dataset such as a feature class, raster, or table, and creates a resulting output dataset. In this section we go through some of the most useful geoprocessing tools. You can use the same way to apply other geoprocessing tools as well. The first useful tool is Clip tool. We use this tool to cut out a piece of one dataset using one or more of the features in another dataset. There are several ways to apply the clip. You can use any of them to apply this tool. As an example, here we have a fault layer around the city boundary. We intend to retain the faults that are inside the city boundary only and cut the out-boundary faults. For this purpose, we will use the clip command. To reach the clip tool we can go to Geoprocessing menu and find the clip command. And another way to reach is the search section of the software. Here you should just search for clip command. And select clip analysis. In the input features section, we select the fault layer as a layer we want to be cut. And in the clip features section, we select the city boundary layer as a layer we want to cut the fault layer based on. Save the output layer in a suitable folder. And finally click on OK. Here you can see the output of the clip tool. Only the faults retained that are inside the city boundary. Buffer is another useful geoprocessing tool that has many uses. Buffer in GIS is a reclassification based on distance, classification of within/without a given proximity. It can be generated around all the vector layers. Here we have the fault layer inside a city boundary. The effect of the fault layer in a range can be extracted with the buffer tool. For this purpose, we go to the Geoprocessing menu again. And select the buffer tool. In the open window, we select the fault layer in the input features section. We define a specific storage path. In the other section, we specify the buffer distance. The unit can be changed. We determine 70 meters as an example. Here you can see the 70-meter buffer. This is one of the uses of the buffer. Now we can see where the earthquake has the most effects because we have the fault layer. We increase the amount of buffer. Here you see the 200-meter buffer. We will also make another buffer of 1 kilometer. In the same way, you can specify the buffer based on the topic you're going to deal with. Another useful tool in GIS is the Merge tool. Merge tool combines multiple input datasets into a single, new output dataset. This tool can combine point, line, or polygon feature classes or tables. Here we have several separate layers. We are going to convert all the layers into one layer but with the same layer information. So we go the Geoprocessing menu and select the Merge tool. In the open window, in the Input Datasets section, select all the layers you want to merge. In the Below table, the selected layers are added. Determine a storage path to save the merge output and set a name for it. And finally click on OK. Here you can see the Merge to layer, which all the selected layers have been converted into one layer. The next tool is Dissolve tool. The Dissolve tool unifies adjacent boundaries based on common attribute values. Only if neighbor polygons have the same dissolving attribute, then it melts the boundary into one. To perform dissolve on our layer, we go to the Geoprocessing section and select the Dissolve tool. We define the desired layer. You can do dissolve based on any field you need. Here we generally perform operations on our layer and change the output storage path. Here it is clear that our layer has dissolve operation applied on it. If you have a DEM file and you intend to work on it, we will go through its preliminary training in this step. A digital elevation model or DEM is a digital representation of ground surface topography or terrain. As you can see, we've imported a DEM layer. In the visual representation of a DEM layer, based on the layer legend, you can see the areas with higher height in white and the areas with lower height in dark black. Lines can be seen inside this layer, which indicates the existence of a river in this watershed. For this reason, these areas are seen in dark black. A combination of different colors can be used to better distinguish the area. By inverting, you can reverse the black and white display. You can also choose different color combinations. And see the areas with difference in height better. By clicking on the layer, the height value of that pixel will be displayed. You can also display it as a unique value, or as classified. You can choose more or less number of classes. Choose the right color combination, and have a better view of your area. To extract slope, we go to the search section and search for the slope command. In the open window, we select the DEM layer. Save the file in a specified path. Choose as a percentage. And click on OK. Here you can see the slope of the DEM layer. The redder the areas, the steeper the slope. And the greener areas show a gentle slope. It can also be exported in degrees. In the next step, we extract the contour lines. Search for contour in the search field. In the open window, select the DEM layer. Specify the distance between the contour lines. Save the output in a path and write a name for it. You can increase the distance between two contour lines. Therefore, we apply this command again. By clicking on each line, you can see its height value. In the lower areas, the height is lower, and in the upper areas, the height is higher. In the last step, we extract aspect. Insert the DEM layer. Specify the output path and write the name. In the output, you can see which direction the heights are. Here are the highlands to the west. And here are the heights to the east. If you like this tutorial, please support us with likes and comments. And if you need a specific tutorial, let us know in the comments so that we can record a video for it.